Hello, this is Mr. Wyrick. Today we're going to be talking about lesson 11.2, the second lesson from chapter 11, the areas of trapezoids, rhombi, and chites. So the rhombus, the chite, the trapezoid, those irregular quadrilaterals, we're going to be talking about how to find the areas for those. The first thing you need to make sure you have in your notes is the definition, the height of a trapezoid, and again it's perpendicular, but usually when we're talking about distance, that perpendicular doesn't necessarily have to be stated. But we're talking about the difference, the distance here between base number 1 and base number 2 here in my trapezoid. So this is a base, we'll call it base 1. This is a base, we'll call it base 2. It's kind of arbitrary, whether it's 1 or 2, it doesn't really matter. And this is going to be my height. Now, it doesn't matter in this case if I have an isosceles trapezoid, where these are perfect with one another, or if I have some of the ones where it's kind of squared off on one end and then comes down to the other end like that, it's still going to work out exactly the same way, except in this case, if this is a 90-degree angle, this line is going to be my height. Here's going to be base 1, here's going to be base 2, and I'm good with it. The formula they give you after that, remember that the bases are the parallel parts of the trapezoid. So if you're like, wait, which one's the base? It's always those opposite sides that are parallel that are the bases of a trapezoid. To find the area of a trapezoid, it's going to be 1/2 of the height times base 1 plus base 2. Now, I've never liked that as a formula, so I try to think of it a different way, a way that makes more sense to me, and I say it's the average of the bases being multiplied by the height. Okay, so if I've got my trapezoid over here, this one's 5 and this one's 7, I say, okay, 5 plus 7 is 12 divided by 2. I average them together and I get 6. So I'm going to multiply 6 by my height. And that will be effective. Again, essentially, I'm going to cut a triangle off over here and reattach it on the other side. So I've got the area addition postulate coming back into work here to make it into a rectangle. If it's irregular, it doesn't matter. You could actually do the cutting to a spot where you're attaching it and saying, okay, this is my perfect trapezoid and this is what it's going to look like, and here it is all together. Okay, so again, I average those bases together and multiply it by the height. You can think of it that way, or you can just memorize this formula: 1/2 times the height times base 1 plus base 2. So this would be 7 plus 5 is 12 times 6, or whatever my height is in this case, and it'll work either way. 12 times 6 would be 72, divided by 2 would be 36. Or if I add these together and say it's 12 divided by 2, that'd be 6, times my height of 6 would still be 36. So it will work out. Think of it whichever way works better for you, and probably just erase the other. Unless you're going to be relying heavily on a formula chart at some point, it does not matter. The next one is talking about area of a rhombus, which is also the same for area of a chite. All you have to do is find the diagonals. Once you know the length of those diagonals, then you multiply diagonal 1 times diagonal 2 and divide by 2. Okay, you multiply 1/2 times diagonal 1 times diagonal 2. Essentially what we are doing is, in our minds, we are creating a rectangle that this chite or this rhombus is going to be inscribed in, and saying, okay, instead of the full rectangle, I have a triangle here, I have a triangle here, I have a triangle here, I have a triangle here. A lot of these formulas are based on having to work with a triangle, or splitting the shape that we have, no matter how irregular it is, into triangles. Okay, so if we have the rhombus, if we have the chite, we have this formula that's great, and if the formula won't work out because we're missing too many measurements, we can always work backwards and we can find those individual triangles, find the areas of the triangles, and go back to that area addition postulate. If I found the area of all 4 of these triangles, then by adding them together, I have found the area of that chite. If you can find the area of a triangle, you can find the area of most of these quadrilateral shapes, the squared off ones. You'll be good right up until we get to circles, semicircles, something like that. On page 792, there is a guide, a set of formulas. If you want to take that down in your notes, that's a good little cheat sheet to kind of refer to based on whatever shape you're going to be dealing with. We're going to be doing quite a bit of the work today again, just because, again, It's not like these formulas are overly complex or there's a ton of thinking that's going to be involved in working through it. It's mostly just math, math, math all the way through. So numbers 8 through 36 on this lesson will be what we'll do. If you have questions about it, you don't understand something the way I explained it here, make sure you come in, talk to me in class, and we'll get it worked out. I'll see you then.